Theorem 8 talks about two tangents. As you can see, the property that applies when we have two tangents. So let us read it out. Two tangents to a circle drawn from a single point outside the circle are the same length. Okay, so whenever we have two tangents that meet, okay, from a single point outside the circle, that will mean that they are of the same length and they create congruent right-angled triangles. Now, by congruent, what they mean is that they are same in every respect. Okay, their size is the same, their angles are the same, their length are the same. So whenever you have two tangents that meet from an external point, that means that their length is the same, as you can see, as indicated by these lines right here, this one and that one. That indicates or denotes that the length of this line is the same as the length of this line. So that's what it means. And they create congruent right-angled triangles. So these triangles are exactly the same. Their angles are the same, their sides are the same, everything is the same, and the size of the angles, the triangles are exactly the same. I'll show you very quick when we enter into our beloved app. I just want to point out something. There are a lot of, this is, by the way, a topic in senior secondary, similarity and congruence. So in similarity and congruence, we talk about how things relate to each other. For example, how the comparison between two shapes or figures. Okay, so to be similar means that it's like exactly the same except for the size. Like when you are looking at a replica of a car, a prototype, a toy car. When you look at a toy car, it looks small as compared to the actual real car, not so, but the dimensions are the same. You find that it's only the size that has been shrinked, whereas something is congruent means that it's exactly the same thing. It's like looking at your own twin. You have the same eyes, the same ears, the same body mass, not body mass as in mathematics, but what I mean is that the outwards appearance, okay, the image, okay, it looks exactly the same. So congruent means that everything is the same. Similar means that everything is the same except for the size. Whereas congruent means that the size and every aspect is exactly the same thing. So that's what I'm trying to point out. So let us read the other point here. The other point says that two triangles are congruent if both are the same size and have the same angles. So this is exactly what I'm just from pointing out. Okay, two triangles are congruent if both are the same size and are the same angles, and that's what this theorem states. When two tangents to a circle drawn from a single point outside the circle, that will mean that they have the same length. Okay, so as you can see, I want you to observe just a moment what I'm trying to talk about here. We all know that the radii of the circle, that is plural for radius. Okay, we know that this radius is equal to this radius, so this means that this radius and this radius are equal. Then again, the theorem says that the tangents to a circle drawn from a single point outside the circle are the same length, so which means this is the same length as this. So as you can see, if you look at this part here, it says that in order for us to have two triangles that are congruent, both have to have the same size and the same angles. This means also the same length. Okay, so as you can see, this radii is here for this triangle and this is equal. this length here and this length is also equal, and this middle length, because they are sharing a border, as you can see, so therefore it's the same. Therefore this is they form a pair of congruent triangles. So enough of that, let us go straight to GeoGebra. So I'm going to start by adding a circle like so. So now I've added a circle. Let me just get rid of this. For some reason it disturbs me quite a bit. So let us add a point. We're going to add a point, so the tangent is going to touch the circle at that point. Another tangent is going to touch the circle at that point, because remember in the theorem we have two tangents. Okay, so now let us go to our tangent 2 and let us create this tangent. So as you can see, that's one tangent, that's another tangent. So now let us move the tangents so that they meet at a certain point. As you can see, they are meeting here. So let us denote that by showing their intersection. So let me create this tangent and this tangent. As you can see, they are meeting at what? They are meeting at point E. So when I move them, as you can see, they are meeting at point E. So now, what else? Let us create the radii of the circle. So let us add a radius like so, another radius like so. So to simplify things, let me just change the style of this radius to a dotted one, so that you can see that this is the radius. And as you can see, those are the radii of our circle. Lastly, let us add a point like so. So as you can see, this is what the theorem means. So as you can see, this is what the theorem is talking about. So this middle line, I'm just going to color it blue. Okay, like so. So as you can see, this is what the theorem says. When we have this tangent and this tangent meeting from an external point, means that they are not meeting inside the circle. As you can see, they can never meet in the circle. It's always outside. When they meet, they form their size is the same. By same length, it means that from the point where they meet to the circumference, it's the same distance. So EC is the same distance with ED. So let us measure and see what they mean, same distance. You are going to see that that's what they mean. As you can see, ED is 8.9 units. So let us measure EC. EC is also 8.9 units. So as you can see, these tangents are of the same length. As you can see, there is something also added here. They said that they create congruent right-angled triangles. So let me just color them by making a polygon like so. So this will be a triangle. So this will be another triangle. So these are the triangles that they are talking about. I'm going to color this triangle a different color, maybe red like so. So as you can see, this red and the blue are the triangles they are talking about. So these triangles are exactly the same. They are congruent. As you can see, when I move them, they are basically the same. So to prove that they are basically the same, first of all, let me measure the angle, because the theorem stated, if you see here, right-angled triangles. As you can see, right-angled triangles. So let us measure and see if truly these angles are right angles. As you can see, okay, so that's a 90 and that's a 90 right there. If you remember the theorem in the previous lesson, it talked about the radius and the tangent form a 90. So this is where this 90 is coming from. And as you can see, the angles are the same everywhere. As you can see, so this is basically what they mean. If you see, this length is the same as this length, and the angles are also the same. So this is what it means when we have congruent triangles. So basically this is what the theorem says, as you can see when I shrink it, as you can see. So let me show you a scenario of how a question might come in the exam, and we'll call it a lesson for today. So as you can see, let me just delete this angle. Let me just delete these angles. Okay. So in the exam, let's say, let's just choose an angle. Let me just choose an angle. Let's say we have angle EAC. So let's say that angle has been given like so. Okay, so this is how a question might come in the exam, as you can see. So this is what the examiner might bring. Then in the exam, you might be told to say that find the angle EAD. So now, since you know that these triangles are congruent, which means that this angle right here is equal to this angle we are required to find. So therefore, this angle also is going to be 66.4. So let us measure that. EAD. And as you can see, it's 66.4 because the angles are the same. The triangles are exactly the same, therefore the angles should be exactly the same. If you are required to find this angle ADE, just remember that theorem that we talked about. This is a radius, not so, and this is a tangent. And where the radius and tangent meet, they form a 90. So as you can see, the theorems are like merging together. So now you are truly equipped. No matter how the question comes in the exam, you can apply these theorems, as you can see. So this is 90, therefore even that one right there is going to be what? A 90, as you can see. And if you're told to find, let's say, let me measure this one. Let me measure this one real quick. If you are told to find angle CEA, you already know that these triangles are congruent. So therefore what this will mean is that this angle is equal to this angle. So let us measure it. And as you can see, this is very simple. This is very easy stuff. And as you can see, it also forms a 23.6 degrees. As you can see. So that's all that the theorem means. If you enjoyed this lesson as I did, I know I did enjoy this lesson, consider liking this video, sharing it, and ultimately, if you're new to this channel, subscribe to this channel and be part of this great journey that is all about learning cool and interesting stuff like this. Make sure you subscribe, click on the notification icon there so that you never miss out on any of our future videos. Have a nice day and see you very soon.